Everyone is telling you AI makes coding free. I run 20 engineers shipping agentic code to production, and we've just completed a modernization of an app for a client. And I'm going to show you the bill that nobody puts on the slide. So what happened is that AI made code like really cheap to write, but then it's really hard and really expensive to trust it. Everybody have the same model. You have access to like Fable or Opus or whatever, Sonnet 5, the best and greatest models available right now, and then next week it will be GPT 5.6 or whatever, and will be even more people having access to the same tools. The point is that the model is a commodity that everybody have access to. Trust for generated code is actually becomes super expensive, because previously you would spend a lot of time planning and then a lot of time writing code, and then eventually at each step of the process you would build up trust to your code, to your verification process. But now the development, the writing code part became so much more smaller and tinier, so most of the work and preparation goes either into planning or into the verification, and that's why verification now, i.e. trust, is the most expensive thing I've seen. And one other thing I noticed is that cheap code actually made senior engineer judgment a lot more valuable. Like, how would someone decide, yes, now I trust this system, it works 100% like it should? I really want to talk about 3 separate decisions that we had to work through and come up with the best approach for this particular case. So first of all is the question, what is the agent allowed to do on its own? When I say agent, I mean like Claude Code or Codex, anything that produces code. So the first decision we had to make is agree, are we gonna configure rules, or we enable the auto mode in Claude Code, or we're just gonna review all commands? Like, let's be honest, nobody does that now. Most of the folks, they go for auto mode. Now, if that's the case and you have a lot of external systems, you have cloud providers, you have database, you have some third-party API, you really want to make sure that you're protecting the real data and interaction behind like a separate access. For example, for cloud providers, create a separate service accounts with read-only access. We're using Temporal for workflow orchestration. There you go. If you want an agent to access Temporal to read the workflow and do something with it, create a separate service account, give it a read-only access, and then you can pretty much be sure agent wouldn't screw up because, I don't know, a bug or hallucination or whatever. So basically for every external system that we worked with, we've made sure we had an account with read-only access, and it was configured like as a shared standard thing for coding agents, and nobody was using their personal things, which helped a lot. Let's talk about situation. You're working on a feature, Claude Code did wrote your entire feature in like 5 minutes. How can you trust what it wrote is actually correct? How would you do that? Automated acceptance tests. Before the functionality even exists, where you have like just the idea of what it should do, what your product is, and you're just starting to work through use cases and through scenarios. As part of that, you're just basically going in and saying, hey, when this use case happens, I expect certain other things to happen on my side. When the user clicks a button or API call comes in, I expect certain things to happen on that other end. That's what acceptance tests should verify for you. And when done right, you build out a system that just scales with functionality, and you always know that it works. Like a lens I have for this, input, output, function, state. You control the input and then you verify the outputs, and then you call in a function and then you can double check the state. I've talked about this like in a few other videos, you can check for that. So going back to the question of how you can trust the code that was generated by an agent. If you have coverage with automated acceptance tests, and you know each of the use cases and scenarios map to a specific functionality within the application, and when you execute and verify the outputs for a given inputs, that's how you will make sure that the actual code works. It's really tricky to get done right. There is one specific approach that I think works. It's based on the 3 layers. So DSL is how you write your test cases, the actual test cases obviously, and then the interface for API layer, API calls, API functionality, browser. And here is the next kind of thing that we've implemented as part of the harness for this application is we really worked through the context that gets loaded by the coding agent. So it wasn't just Claude MD with some rules. We had product vision, we had a roadmap that's going for like, I don't know, 3 months out, but still there was like some kind of plan and the idea and the product context, what we are working towards. So it wasn't just like one-off interactive session that you just open up Claude and you just like go in with it, right? I think the real value is having a structured approach to development where in addition to the code base, you actually have information from the product, from the architecture, maybe even some metrics that you can share. And after that, the agent can call in and pull in the right context at the right time. And then that's how you iterate and you get even more value add, especially when thinking like higher level in terms of what feature to add or how it should be deployed, how it should be delivered. And this is again, you expose more information into agent and agent creates better solution that you verify with automated acceptance tests. And that's how, in my opinion, you build up that trust between the code that was generated in 5 minutes and the functionality that needs to be working and expected by the business. I think the important realization was that a harness isn't just like your set of configurations with hooks, some other standard MCPs and whatnot. It's actual a set of decisions that you've made and you like thought through how you want them to behave and be treated before you start using it. And of course, iteratively improving. But the most important part is that that was intentional, that you thought about them, you shared with the team, and then you decided to carry over those decisions and try them out. For me, that's the whole like loop of iterating on a harness to enable coding agent to generate a code that you can trust. Every time I see a pull request and I could see it was just generated with Claude code and the person haven't even looked at the freaking files. There's just like dumbest stuff possible in the pull request. The moment you open it on the GitHub and you see file was generated or a piece of code and you're like, that's not going through my linters, that's not going through automated acceptance tests. The goal is to shorten the time required to get from generated code into trustful functionality. And of course, that's why I think the whole AI thing made a senior engineering judgment a lot more valuable in the context of a company than just like, let's get more stuff out with this like vibe coding stuff or Claude code. Again, alignment, verification, and then if you have that, you can then just like go and create your code however you want, because at that point a person can write it, an AI can write it, like it doesn't matter because you have a clear set of expectations for your inputs. If you give certain inputs into the system, you expect certain outputs. So now you just need to fill in the middle, and how you do that is really up to you.